Hello guys, welcome back to my YouTube channel. Today I am going to solve day 13 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. So today I am going to solve LeetCode problem number 85, Maximal Rectangle. So this is a hard level problem, and in this problem we have given a binary matrix, okay, with zeros and ones only, and we have to find the largest rectangle containing only ones, and we have to return its area. Okay, so see, this is example 1 given to us, right? So in this example we have to just consider the area where we find this one only, right? So we have to just consider the ones only, right? So let's try to find the area. Okay, first of all let's try to find the area. So if I consider this part only, okay, because in this part in every cell you see one, right? So if I consider this part, then what is going to be my area? So in this case my area is 4, right? And if I consider this part, this red color part, okay, then what is going to be my area? My area is going to be 3, right? So how this 4 is coming? My height is 4, right? Let's say it is my length, and my width is 1. 4 into 1, how this is coming? So here in this case my length is 1 and my width is 3, right? So this is my length, okay, and this is my width. Okay, so this is how I am considering. So we can treat this length as height as well. Okay, so whatever you want to consider, okay, it's up to you guys. Okay, so if I pick this this part only, then again my area is going to be 3. Okay, but if I pick this part, so in this case what is my length? My length is 2, right? My length is 2. And what is my width? My width is 3. Okay, so my area is going to be 6. And is there any other case where we find the maximum area? No. So this 6 is a maximum area that we have found, right? So this 6 is going to be my output. Okay, so this is what we need to do. Okay, so now let's do one thing. Let's understand, this is a 2D array, right? So this is a little bit complex. Okay, so let's say if if 1D array is given to us, okay, and in 1D array, let's say these are the elements, okay, 1 0 1 0 and this 0. Then in this case we have to find the max area. Then how you guys are going to do this? Okay, so this is 1D array only, okay, right? This is 1D array only, okay, and this is my length, and length is just 1. Okay, length is just 1, and this is going to be my width. Okay, in this way I'm going to check it for the width. Okay, so max area in this particular case is going to be 1 only, right? Why? So see, for this this is 1. Let's say this is one building, okay, this is one building, okay, and this is 0, so we don't want to consider it. Then this is one building, right? This is one building, and yeah, so these two are the only shapes that I have found. Okay, so we have to just find the area of rectangle. So length is 1 and width is 1 in both the cases, right? So what is my maximum area? My max area is 1. Okay, so diagrammatically we can show it like this. Okay, this is my building 1 and this is my next building of same height, right? Both buildings have height 1 and all other buildings are 0 only. So these two are the only shapes, right? These two are the only shapes. Okay, and so that's why we have find the maximum area as 1. Okay, so I have just picked this part. Okay, I have just picked this part. Okay, now what this is case of 1D array. Okay, now what if I join these two? Okay, if I just pick these two, first and 2. Okay, so let's say I am going to pick only first 2 rows. Okay, so if I pick these first 2 rows only, okay, first 2 rows only, then in this case I can represent my building like this. Okay, so let's say there are total 5 buildings, and one first building height is 2, right? This is 1 unit and this is 1 unit, so in total I can say this building height is 2. Okay, this building height is 2. 0 plus 0, so no building. Then again there is one more building and this building's height is 2. Then after that this building's height is 1, and then after that again this building's height is 1, right? So diagrammatically I can represent it like this. So now in the last case, when I just pick a single row 1, okay, in this case I have just picked row, let's say row 0, okay, so indexing index wise, okay, row 0, row 1, row 2, row 3, this is column 0, column 1, column 2, column 3, column 4, okay. So this is for when this is the case when I am picking both row 0 and 1, okay. So right now I am picking both the rows, okay. So this is how buildings are looking like, right? So in this case I have to find the max area, okay. So let's see what's the max area in this case. So first of all I am going to start from here, okay. So there is no building attached to this one, okay, this is just a single building, okay. So I am going to find the area of this one, okay. So area of this building is 2 into 1. 2 is the height, right? 2 is the length or height, whatever you want to say, and this is my width, right? So 2 into 1, 2 is the area, right? For this building it's 0 only na, okay, there is nothing, so we don't need to calculate the area for this part. For this building what is going to be my area, okay, for this building what is going to be my area. So my building looks like this, right? So see, this is my building, right? This is my building, okay, this is my building. And what is the max what is the area for this building, okay. So length of this building, what is the my length? So length, height, right? So what is the length of this building? 2. And what is the width? These buildings are smaller, right? If I don't want to consider this width, I don't want to consider this width for this particular building, okay. I can only consider this width if both the buildings are of small or are of same size. If let's say if this building is also of 2, then I can consider, right? Otherwise I can't consider. This is not a rectangle because this area is 0 right now, right? So I hope that you guys are clear. So here 2 into 1 is nothing but 2 only, okay. So what is the area of this building? Area, max area 2 only, okay. So I can't consider this part, right? So I am not just adding the width as 1, okay. So now I move to the next building, okay. So for this building I am going to check. So height of this building is 1, okay. So see red color cursor. So height of this building is 1. So I am writing it here height. And what is my width? Okay. So see here in this particular case right now, I in the both in the left and the right, I have seen the values which are equal to this or greater than this. Okay. Okay, this is a building, okay, this is one building, right? In the left side also I am seeing the same height building, and in the this is in the right side, and in the left side I am seeing the building which has more height than this. Okay, so I can consider both the buildings, right? I can consider this part, okay. This is forming one rectangle, right? No matter this building is higher, but this is forming one rectangle, right? This is forming one rectangle of 1, right? 1 1 1, right? So what is going to be my width in this case? 1 into 3, that is nothing but 3, right? Now I move to the next building, okay. So when I am here, so height of this building is 1, and what is the width? So again, see, we are going to check for the buildings which are greater than or equal to our current building, okay. If any building is smaller than our current building, then we don't need to consider that. But if there is a building which is of same height or greater than our current building's height, then in that case we have to consider that as width, right? So 1 into all these 3, okay, 1 into 3. So what is going to be my area? 3. So in this particular case, so max area that I have obtained is 3, right? Max area that I have obtained is 3. So here in this case, when my when I pick just row 0, then my max area was 1, okay. Now when I pick two rows, row 0 and row 1, so now my max area is nothing but 3, right? So I hope that this is clear. So see, diagrammatically you can see in this example, so this is the max area that you have found, right? So I hope that this is clear. Here the max area is 2, here the max area is 2, and here is the max area is 3, right? So I hope that this thing is clear. So now I am going to pick row 0, 1 and 2. Okay, so let's pick row 0, 1 and 2. Okay, okay. So now in this case, let's make a diagram. Okay, let's make a diagram first. So my first building height is 3, right? My first building height is 3. My next building's height is 1. My next building height is 3. I am adding all this, right? My next building height is 3. My next building's height is 2. That done. And my next building's height is 2 again. So this is done. Okay, now let's find the area one by one, okay, of all the buildings. So first of all, for this building, what is my height? Height is 3. And what is my width? Width is 1 only, na, because this area is empty. This area is empty, right? This area is empty, so I can consider only this part. Okay, 3 into 1, so it's 3. Okay, so you know guys already know, so this is a rectangle, right? This is not a rectangle. This is not a rectangle, right? This is something else, right? So this is rectangle, this is the rectangle, right? So that is why 3 into 1 is 3. Okay, for this particular building, what is going to be my height? Height is 1. And width, okay, so I am going to looking for the buildings which are of same height as my current building, or the buildings which are of greater height. Okay, so I am going to consider all this part. Okay, so this building, all these buildings, okay, they will form one rectangle here. Okay, because all the buildings in the left and right of this my current building are greater than or equal to my current building. So 1 into how many buildings? 1 2 3 4 5, total 5 units I can say. Okay, so 1 into 5, 5 is the area for this building. Okay, so for this particular building, so my height is 3. And what is my width? So width is going to be 1 only, right? Because all the buildings which are surrounding this building in the left and right are less than, okay, are smaller than our current building. Okay, are smaller than our current building, so I don't need to add anything in my width. So my area is 3 only. So for this building right now, 2. Okay, for this building my height is 2. And what is my width? So my width is going to be this, na. So I can consider complete this as one rectangle, right? Because this building has same height as of my current building, and this building has more height as of my current building, so I can consider this building. But I can't consider this building because this building is of smaller height. Okay, so this is a rectangle, this is not rectangle, right? So you guys are clear, right? So this is one rectangle that we are forming, right? So 2 into 3 is nothing but 6. And same way for this building, height is 2 and our width is 3. 2 into 3 is 6. So see, so what is the max area that we get in this case? So max area that we have got in this case, max area is equal to 6, right? 6. So see, in diagrammatically it is clear that we are picking this triangle. Okay, we are picking this rectangle. Okay, so in this rectangle we are getting the max area, right? Max area is equal to 6. So I hope that this is clear now. So in this particular example, we are picking row 0 1 2, right? So see, this is our output. If we pick just this, then my area is 3. Here my area is 3. Here my area is 5. Okay, so this is the only right answer, right? So max area is equal to 6 if I pick row 0 1 2. Okay, so now there is one more point. Okay, now let's understand this with all rows. Okay, so see, now I am again making one building. Okay, I am going to make buildings, right? So here, okay, this is index 0 1 2 3, 0 1 2 3 4. Okay, so here this building's height is 4, right? So I am making one building of height 4. So here I am making one building. See, I can't make this building because this is my ground level, right? This is my ground level right now, and here it is showing 0. Okay, so definitely there is not going to be any building like this. Okay, so this is not, we can't stand the building in the air. Okay, so if in the ground level, okay, if 0 value is there, then I'm not going to make that building. Okay, because our building is not going to be in air. Okay, so here there is no building, then here also there is no building, so I am leaving empty space. Here there is one building of height 3. Okay, so here I am making one building of height 3, and here empty space only because it is 0 na, ground 0, so I can't just build a building like that. Okay, so it's not standing in air, right? So these two are the buildings right now. And what is the max area? So max area this time it's very clear, for height and width is 1 4, and here what is the max area? 3 into 1 is equal to 3. So in this problem we have found we are not going to update our max area, right? Why we are not going to update our max area? So see, this time last time we have found max area is equal to 6. Okay, for this particular example we are just considering the max area na. So in this case we have found area like 4 3, but this is not greater than our max area. Okay, so I'm not going to update my max area, and see the output of this problem is 6 only, right? So I hope that you guys are clear with how I'm going to solve this problem, right? So now two important things that we need to understand first. uh, First, how we are going to calculate the width of buildings. Okay, so here how I'm calculating the widths. Okay, this is what we need to know, how I'm calculating the width of a particular building. Okay, for this building how I'm considering that is it is 5. Okay, so for this actually there are some separate questions. Okay, so we can say like NSR, NSL. Okay, so next smaller element that we are going to use next smaller element, or next smaller element to the left, next smaller element to the right. Okay, till there we can make the bits. Okay, so let's understand it like this. Okay, so here let's say uh, let's say there are a total, this building's height is 2. Okay, so now let's say this building's height is 2, this building's height is 1, this building's height is 3. Let's say this building's height is 3, this building's height is 1, this building's height is 3, and this building's height is 1. Okay, so now for this building, this particular building, we know the height is 2, we know the height is 2, right? And what is going to be my width of this building? Okay, so diagrammatically the buildings are looking like this: 1, then 3, then 2, then 3, then 1. Okay, diagrammatically buildings are looking like this. Okay, so for this building I have to find the width. Okay, so diagrammatically it is clear that width of this building is going to be like this. Okay, maximum rectangle that we are going to form, it's going to be like this only. Okay, so how we are going to calculate this width? That is nothing but 3 here. Okay, so what I'm going to do here, I am going to find the next smallest element to the right of this current building's height. So next smaller element is here. Okay, after 2, what is my next smaller element in the right? So at this particular index it's there, right? So here I am writing index 0 1 2 3 4. Okay, so next smallest element to the right is at index 4. And what is the next smaller element to the left of this current building? It's here. Okay, so next smallest element to the left of my current building's height is at index 0. Okay, so now how I'm going to calculate this? I need the answer like 3 here, na? 3 bits. So how I am going to make that? So I am going to use this formula, next smallest element to the right minus next smallest element to the left minus 1. So 4 minus 0 minus 1 is equal to 3. Okay, so this is the formula that I am going to use to calculate the width of my buildings. So I hope that this is clear. Next smallest building to the right of my current building, next smallest building to the left of my current building, subtracting them and then subtracting minus 1 from that. Okay, so this is how I am going to calculate the width of buildings. Okay, so I hope that this is clear as well, right? So this is done. So now I am going to write the code. So I am going to explain step by step whatever I am writing. I'm going to write in the code. Okay, so just focus. Okay, so first of all, here rows equal to matrix dot length, and okay, so here first of all let's write one base condition. Okay, if matrix dot length, okay, matrix dot length is equal to 0, this is a char array, right? Matrix dot length is equal to 0, then in that case just simply return 0, right? So if there are no rows and columns, just return 0. Okay, so we are not going to form any area. Okay, so this is done. After that, let's we are going to rows by rows, right? So first of all, let's find the length of this matrix. Okay, how many rows are there? So for that, write like this: int rows is equal to matrix dot length, and we have found how many number of rows. Now let's calculate the number of columns. Okay, so number of columns. So let's to calculate the number of columns. So let's pick one row first. Okay, so let's say I have picked a row number 0, and let's calculate the length of this row. So in this way we are going to get the number of columns, right? So now this is done. Now let's create one height array. Okay, in this height array, it is going to be have the same number of as calls, right? New int calls. Okay, how many calls it has? Okay, this is going to check for the heights. Okay, then max area that we have to find. Okay, this is what we need to return in the end. So initially my max area is equal to 0. Okay, now after that we are only going to select the buildings which in the ground level if they have one only. Okay, so here I am running one loop. Okay, so for int I is equal to 0, I less than calls I plus plus. Okay, I am iterating over first row. Okay, let's say. So here how I am going to calculate the height of the building. So height of I of the current building, height of current building. Okay, so if I pick this building first row, okay, height of I is equal to be my matrix matrix 0 row, right? I, okay, if it is equal to 1, then in that case I have to select 1, otherwise 0. Okay, so actually why I am doing this, because see here matrix characters are given. Okay, so I am just changing it to number. Okay, so that is the reason I am making it like this, right? So I hope that this is clear. So this is a character matrix, right? So these are the characters only. Okay, 1 0 1 0 0. Okay, so here I have converted to the number. Okay, so if matrix of 0 of I, okay, if it is one char, then it is going to have one number. Okay, so I hope that this is clear. Now max area. So how I'm going to write one function. Okay, so how I'm going to get the max area. Okay, so max area is equal to length into height. Okay, length into width, whatever you want to say. So max area is equal to, so here I am going to define one function, max area histogram. Okay, max area of histogram height. In this I am passing the height. Okay, so why I am creating the function like max area histogram? So see here, I think this question is linked. Here's the max largest rectangle in histogram, opening into tab. Okay, so see, this is how I have explained the code, right? So after solving this, you guys can just go ahead and solve this type of problem. Okay, both are going to be similar only. Okay, so here max area is equal to max area histogram height. I am passing the height. Okay, and once we calculate the area for our first row, then after that we have to find the areas for our upcoming rows, like row 0, 1, row 2, row 3, right? So for that I am going to run one loop. For int I is equal to 1, I is less than rows. Okay, row by row, I plus plus. Then for int j is equal to 0, j is less than quotes, j plus plus. Okay, and here also again same thing. If matrix of ij, if it is equal to 0 char, okay, then height of j is equal to 0, right? Else height of j plus is equal to 1. Okay, so I am going to just increment the height by 1. Okay, if it is 1, this is done. See here, every time I am just adding a height now. So see here, when there was this was just single row. Okay, when I select one more row, then if I found that in my second row 1 is there, so my height is updated to 1, right? Here it was 1, so it is updated to, okay, right? Here it was 0, so it's remain 0, 1 only. Here it's 0, it's remain 1 only. Okay, here it's 1, it will become 2. Here it's 1, it will become 2. Okay, right? So this is done. Now after that we have to just calculate the max area. Okay, max area is going to be math.max. Okay, and in this we are passing the max area that we have calculated for our first row, and for the upcoming rows whatever area that I'm going to find. So here just I'm going to call this function here again, max area of height for the upcoming heights that I have added here. Okay, so this is done. And in the end we have to just return the max area. So this is our main function. Okay, now we are going to define all this max area histogram and everything. Okay, so this is done. All right, now after that this is our main method to find the rectangle area. So here let me write main method to find the maximal rectangle area. in the binary matrix. Okay, so this is done. Now after that, let's define these functions as well. Okay, NSR, how we are going to calculate NSR and NSL. Okay, so here I am going to write public int next smaller to right int of heights. Okay, so here we are writing the method to find the index of the next smaller element to the right, NSR. Okay, short form. Okay, so here now let's define this method. So here first of all I am taking one stack. Okay, I am going to use stack here inside this stack of integer. New stack, and n is going to return me the heights dot length. And one pseudo index initially, let's set it to n. Okay, so I am going to use this pseudo index for the elements with no smaller elements. Okay, and then create one right array. Okay, or you can say NSR. Okay, this is the right array. New int n, and then we have to run one loop for int I is equal to n minus 1 I plus plus n minus 1 I is greater than equal to 0 and I minus minus, and I am here checking while my stack is not empty. Okay, so here once I write the code for this method, I will explain what I am doing here. Okay, so don't worry. And heights of stack dot peak if it is greater than current heights of I, then in that case just pop the index whatever we are passing in the stack, pop the elements until we find a smaller element, and once this is done, then just pass this right of is. If the stack is empty, then just we are going to pass the pseudo index stack dot is empty. If it is empty, then just pass the pseudo index, otherwise just go for the stick dot peak. Okay, update the NSR index and stack dot push. This is done. Stack dot push. Here we are just pushing the index. Okay, and in the end we have to just return right. Okay, so here see what I'm doing here. So there is one heights array. Okay, so there is one heights array. Okay, so let's say these are the elements in my heights array. Okay, so this is one heights array. So I am, first of all, I am finding my NSR. Okay, so I am going to start from right. Okay, so I am searching for the next smallest element in the right. Okay, so I am going to start from right to left. Okay, so initially when I am at this particular index, okay, for this particular, when I am at this particular index, so my stack is empty, right? My stack is empty. So there is one right array, so I am going to fill the values in this right array. So this is going to be represented as NSR. Okay, so here just I am going to find the next smallest element in the right. Okay, at which index it is available. Okay, so initially my stack is empty. So what I'm going to do, in the right of I here at this particular position, I'm going to start from right to left. So here if my stack is empty, then I am writing the pseudo index. So my pseudo index is set to n. N is nothing but height. What is the length of this heights array? So it's nothing but 5. So here I am writing 5. Okay, so this is index 0 1 2 3 4. Okay, so here I am writing 5. After that I am at this 3. Okay, I am at this 3. Okay, so here one more thing, here I am just pushing the index. Okay, so here what is the index? 4. Okay, so I have already covered this 4 index. Okay, this is done. Okay, this is done. After that I reach here 3. Okay, here in this particular index at this point, then I'm going to check if my stack is empty or not. So my stack is not empty. Then I'm going to check if the top element, okay, if the element here, this is 3, right? Okay, so here what is the top element? First of all, let's tell me what is the top element. So this is index, right? This is representing index only. So this index is representing this value, one value, right? This index is representing one value. Okay, so if, tell me if this one is greater than equal to my current value heights of I, this 3. Okay, so I hope that this is clear. So here once I reach at this particular index 3, at this particular index number 3, I am searching if my stack is empty or not. If my stack is not empty, then I am checking for the value at this index. Value at this index is nothing but 1. If this value 1 is greater than equal to my this value. Okay, so if it is right now it's not true, right? So if it is not true, then I am not going to pop the elements. Okay, but no, right now see heights of stack.peak. So stack.peak is 4. Okay, heights of stack.peak is 1. Okay, 1 is greater than equal to heights of I. What is my I is 3, right? So this is right now, this condition is not satisfied, so we are not going to pop. Okay, so right of I here, my stack is not empty, right? So here what I am going to add, I am just going to add 4. Why 4? Because we have found one element which is smaller than this current element, right? So at fourth index we have found that. Okay, so once this is done, I am going to push this this index 3 in the my stack. Okay, so here see I am pushing the index, right? So here let me do one thing for better understanding. Let me copy this code here. Okay, so this is done, right? After that I move to this position. Okay, 2. Okay, so here when I reach there, I am going to search for the smaller element at this particular index. So this element at this index, I'm going to this particular element. So I'm going to check if this 3 is greater than equal to 2. Okay, so yes, it is true. So I am going to remove this. Then I am going to search for this index. Okay, So if my 1 is greater than equal to 2, so this is false. Okay, this is false. So what I'm going to, if it is false, okay, now it is false. So what I'm going to add in right, if my stack is not empty right now, right, so I'm going to add here 4. Same way, okay, so here I'm going to push the index 2. Okay, this index 2. After that, my I reaches at this position. Okay, so here when my I is equal to 1, okay, I is equal to 1, then I'm going to check if my stack is empty or not. My stack is not empty. Then what is the top element? Stack dot peak. So top index is 2. Okay, add this 2, heights of 2, heights of 2 is 2, right? If this 2 is greater than equal to my heights of I is this one. So 2 is greater than equal to 3. So this is not true, right? 2 is not greater than equal to 3, right? So I reach at this particular position, and here I am going to fill my right of I. So my right of I is, if my stack is not empty, right? So if my stack is not empty, then I'm just going to add stack dot peak. So what is the stack dot peak? Stack dot peak is just showing 2. So right now I am going to add 2. Yes, it is right, because at the 2 index I found the next smaller element to the 3. Okay, then after that I reach at this position. Okay, so when I reach at this position at index 0, so I am going to check if my stack is empty or not. So my stack is not empty, then I am going to okay, one more thing, here I am just going to push. Okay, stack dot push I. So here I am pushing the index, so this index I pushed. Okay, after that, when my I becomes 0, okay, so when my I becomes 0, I am going to check if my stack is empty or not. My stack is not empty, then height of stack dot peak. So here for this height, so this 3 is greater than equal to 1. Yes, it is true, so I am popping this. Then after that, index 2 is greater than equal to 1. This is true, so I am removing this. Then after that, I have found 4. At 4 index I am going to check. So 1 is greater than equal to 1, so this is true. So I have removed all the elements from stack. So now my stack becomes empty. Again my stack becomes empty. If my stack becomes empty, then I am just adding pseudo index. Pseudo index is nothing but n, so 5. So here, see here, so next smaller element to 1, it doesn't exist in my array, right? So here I have added 5. Okay, here I have added 5. Here next smaller element is at index 4. Okay, same way I am going to find NSL, next smaller element to the left. Okay, next smaller element to the left. So how we are going to do that? So that's going to be more simple. Okay, so here I am just going to copy this. Okay, so here I am pasting it here. Next method to find the index of the next smaller element to the left. Okay, to the left, NSL. Okay, so here let's make some modification. It's to right, to left. Okay, then we are taking one stack and it's to hide of pseudo index. So right now change it to -1. Okay, -1, because we are going to move from left to right now. Okay, okay, this is done. Then here right int left is going to 10. Then I'm running one loop, so it is going to start from 0 only. Okay, I'm going from left to right. I is equal to 0, I less than n, and I plus plus. Here I am going to check if my stack is empty, and heights of stack dot peak is greater than equal to heights of I stack dot pop. And here I am updating left of I is, if stack is empty, then this pseudo index, otherwise stack dot peak and stack dot push, and we have to just return the left. Okay, so let's understand what I'm doing here. Okay, so we have write the code for NSL as well, right? So now let's understand how I'm filling the NSL values. I'm going from left to right. Okay, left to right. So initially I'm filling this index as -1. Okay, because there are no smaller values in the left of this one. Okay, then at this 3 I reach. So what is the next smaller element in the left? So this is at index 0 only. At this particular 2, what is the next smaller? This is at 0 only. For this 3, what is the next smaller? So this is at index 2. For this one, what is the next smaller? So it doesn't exist, so -1. Okay, so this is how I am going to fill my NSL, right? So why I am calculating NSL, NSR, NSL? So this is just going to give me width, na, right? So for this 2, what is my NSR? 4. What is my NSL? 0. 4 minus 0 minus 1, 3. So 3 is the width, right? So here there is one rectangle that I found, one width, right? These are the buildings 2, 3, 3. Okay, so here I can form one building, right? That's simple reason, right? So I hope that you guys don't have any doubts here. So these are the buildings like this only, na, if you forgot in case. 1, then 3 height, then 2 height, then 3 height, then 1 height. So this is the only rectangle that we can form, right? Okay, so this is not the rectangle. We are going to consider this rectangle. Okay, because this building's height is 2, so we have to consider the height. And for the current building we are considering the height. Then after that we are finding whether we can expand it or not. Okay, so this is how I'm going to use both NSR and NSL. Okay, so this is clear. So this is done. Now just a few lines of code are pending. Okay, so now we have to just define this function, max area histogram. Okay, this is only thing pending. So here I am going to write method to calculate the maximum area histogram. Maximal area histogram. Okay, so let's define this function. Public int max area histogram, and we are passing the heights. Okay, now int n is going to be my heights dot length, heights dot length, and right array where it's giving us next smaller to right. Okay, right is equal to next smaller to right. Heights, and same way int left is going to give me next smaller to left. Okay, this is done. Then after that width, I am calculating the width as well, right? Width is what I need, right? Int width is equal to new int of n, and max area set it to 0, and then run one loop. Simple. Now just 2-3 lines are pending, right? Max int I is equal to 0, I less than n, I plus plus. Now width, how we are calculating the width? So that you guys already know, right? Width of I is equal to right NSR, right? This is NSR, then my NSL, then I am subtracting 1. That's it. Okay, this is how I am calculating the width. Then what is the formula of area? That you guys already know. It's going to be my width into my height or length, whatever you want to say. So right now we are taking heights, so let's write heights of I, and then max area is going to be math.max of area, comma, max of area, and then in the end we have to just return max area. Okay, so I have written the complete code now. So now let's try to run it. Okay, so now let's solve the issues. So let's see line number 12, line number 29, and line number 79. Okay, so line number 12. Okay, so here let's do this, but this line number 29. So here we have just copy pasted now, so that's why same issue in both NSL and NSR. And then line number 79. So here what's the mistake? 79 max area. Okay, so now let's run it. Okay, so now, okay, so line number 14, there is one issue. So if stack is empty, it's a function, so I have to define it like this. Any other issue? There's one more, line number 31. Okay, so let me modify it as well. Then let's see. So see, all the test cases has been accepted now. Finally our solution runs successfully. So now let's submit the code. So our solution is accepted as well, right? So see here, we have understood a lot of concepts actually in this problem. We have found how we are going to calculate the next smaller elements to the right. We have also made one method to find the next smaller element to the left. Okay, then we have added one method to calculate the maximum area of histogram. Okay, you can say it MAH, max area histogram. And then this is the main method. Okay, so here quick recap. So this is the main function that is given to us. Okay, and after that we are checking if the matrix dot length is equal to 0, then in that case simply we are returning 0. Okay, then we are going to check for the number of rows and the number of columns in our matrix. Then this is the heights array. Okay, and this is the max area that we are taking initially. Then for the first row in our matrix, okay, matrix of 0 0 5, since characters are given in our matrix array. Okay, so if character 1 is there, then we are treating it as one number, as a number 1, and if it is not character 1, then we are treating it as 0 number. Okay, then this is how I am calculating the max area. So for max area I am calling this function max area of histogram height. So here I have called this function, and here I have passed the heights. Okay, whatever the heights in our row 1. Okay, so once we pass the heights, okay, so this is how I pass the height. Okay, so I have just passed the one row. Okay, so I have passed the heights of one row only. So n is equal to heights dot length. So number of simply it is just showing the number of columns, right? The number of calls. Okay, so heights dot length. Then right and left, I am for right and left I am finding the width now. So for width I am finding NSR and NSL. Okay, so for that purpose I am calling this function, and then I know how I'm going to calculate the width. So for the width, this is the formula. Okay, for a particular building. Okay, so here I am calculating the area, and if this area is greater than the previous max area, then I'm just going to operate and return that max area here. Okay, so I have already defined the functions NSR and NSL. Okay, here. So, okay, so this is NSL, right? So I hope that you guys are clear with this video, right? And if you guys still have any questions, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.